In this video, I will be going over my solutions to problems 7, 8, and 9 on the 2025 AIME I. Okay, so let's start off with problem number 7. The problem tells us that we have 12 letters A through L, and they're randomly grouped into 6 different pairs, and in those pairs, they're alphabetically ordered, and then those pairs are alphabetically ordered, and then we have this sequence of 2-letter words, and then we're asked to find the probability that the last word listed contains G. Okay, so first of all, what this problem is saying is that, so if you have like a 2-letter word AG and GA, these are basically the same thing because a GA automatically gets reordered to AG. So basically order doesn't matter here, so that's an important thing to know. Okay, so basically for the last word, the last word has 2 different letters, right? So G can either be the first letter of the last word, or G can be the second letter of the last word. So let's just do casework on that. So case 1, G is first letter of the last word. Okay, if G is the first letter of the last word, then what do we have? So let's draw out our blanks. This is the first pair, second pair, third pair, fourth pair, fifth pair, and then G and some letter. Since these are going to be alphabetically ordered, the letter coming here has to be a letter after G. So this letter can either be H, I, J, K, or L. So we have 5 choices for this letter, so let's write that. 5 choices for that letter. Okay, and what about the letters coming before G? Right, so first of all, the letters coming before G are A, B, C, D, and F. So, A, B, C, D, and F. And so these 6 letters can be leading in these 5 blanks here. But we have 5 blanks and we have 6 letters. So that means that 2 of these letters have to be paired together in a single word, because we can't fit 6 letters in 5 blanks. So we can choose a pair out of these 6 different letters in 6 choose 2 ways. So without lots of generality, I'm just going to pick L for this letter coming after G here, and I'm going to pick AB for this pair. Okay. So if I have AB for this pair, then I have C, D, E, and F. And then I have H, I, J, K, and I have these 4 blanks remaining. And so the number of ways to basically permute H, I, J, K and the 4 blanks remaining here is going to be 4 factorial, because we can just permute them in 4 factorial different ways. Right, so this gives us a total of 1,800 ways for case 1. So 1,800 ways for case 1. And so now for case 2 is pretty straightforward. So for case 2, we're going to have G as the second letter. So case 2, second letter. If G is the second letter, well then what do we have? So we have first pair, second pair, third pair, fourth pair, fifth pair, and then sixth pair. Okay, since G is going to be the second letter here, what that means basically is that we have to have F being here, so that way it doesn't get reordered. And if we have F here, then that means that these first blanks have to be A, B, C, D, and E. We have to have this because, again, they're going to be alphabetically ordered. And now the letters remaining, we can always permute them, and we'll still have valid, distinct pair arrangements because these are all coming after the letters A through F because they all come after G. So H, I, J, K, and L, and they're going to be permuted in these 5 different blanks. So we just have 5 factorial, which is 120 ways for this case. And so adding these up, we get 1,920 for our value for M. So M equals 1,920. Okay, so now what we have to do is we have to find what N is, right? So what's N? Well, N is just like the total number of ways, right? Because this is a probability question, so first pair, second pair, third pair, fourth pair, fifth pair, sixth pair. So what is N, right? So the first letter has to be A in this sequence, let's say. So if we pick A, then we have 11 choices for this letter. So 11 choices. And so what if I pick B? Well, then I have, this has to be a letter coming after that, so let's say C. So then I have 9 choices for that letter. And this is just going to keep going on and on and on. We're subtracting 2 every time we multiply. So 11 times 9 times 7 times 5 times 3 times 1 is our value for N. Okay, so we have M equals 1,920 from our casework, and N equals this number. And so dividing, we get 1,920 over N. And we can prime factorize 1,920 into 2 to the power of 7 times 3 times 5 over 3 times 5 times 7 times 9 times 11. And then the 3's and 5's cancel out. And so we're left with 128 over 693. And 128 plus 693, that sums to 821. So 821 is the answer for problem number 7. Okay, now for problem number 8. So let K be a real number such that this system has exactly one complex solution Z, and we're asked to find the sum of all possible values of K. And then I is obviously square root of -1. Okay, so this is basically talking about magnitude. The absolute value bars mean magnitude. So magnitude of a complex number, A plus BI, is going to be the square root of the real part plus the coefficient of the imaginary part, squared, each of those squared. So that's what this is saying. So that's our magnitude, right? You can also think of it as like absolute value, because this is basically the distance on the complex plane from the origin. It's the distance from the origin to that number. So, but we don't have to worry about that right now. Okay, so whenever we see AIME problems and we're like talking about complex solutions and we have z being a complex number, what we generally want, like what generally helps us out is if we do z equals a plus bi. Because if we do z equals a plus bi, then we can like manipulate the expression a bit more, and then we can probably get into something useful that we can work with. Because like with z, it's a bit vague right now. Like there's not much we can do with just the system alone. So let's do the substitution, z equals a plus bi. So then what do we get? Well, for the first equation, we get the magnitude of 25 minus a plus 20 minus bi equals 25. And for the second one, we get a minus 4 minus k. The magnitude of this plus b I equals the magnitude of a minus k plus b minus 3i. Again, we established what magnitude means, so now we can get away from this wonky like absolute value bars and actually have equations we can work with. So let's convert this into equations. So the first equation is 25 minus a squared plus 20 minus b squared equals 25. Equals 25. This is equation number 1. Equation number 2 is a minus 4 minus k squared plus b squared equals a minus k squared plus b minus 3 squared. Okay, so now look at the second equation. We can obviously expand this out and cancel out a lot of things because we have a squareds and b squareds here, and we have a squareds and b squareds here. So a lot of things are going to cancel. So let's first simplify equation number 2. So I'm going to make equation 2 a bit smaller. Okay, if we simplify equation 2, then we get a squared plus 16 plus k squared minus 8a minus 2ak plus 8k plus b squared equals a squared minus 2ak plus k squared plus b squared minus 6b plus 9. Okay, so we have so many things canceling out now, so this is going to be really nice. A squareds cancel out, k squareds cancel out, the 2ak's cancel out. We're left with this minus 8a here, the 16 here. We're left with this b squared. No, even the b squareds cancel out, so we are actually just left with these terms. So what we have is 16 minus 8a plus 8k equals negative 6b plus 9. Okay, so now I'm just going to clean things up a bit and then convert this into standard form for a line. Okay, so these are our two equations, and we've kind of fully simplified them. So now what do we do from here? Well, we know that we made z equals a plus bi, right? And this problem is saying this system must have exactly one complex solution z. So that means there must be exactly one pair a comma b that satisfies this. It can't be two, it has to be one. So what does this mean exactly? Well, look at equation 1. Well, the thing about equation 1 is we have a perfect square here, and we have like two things being squared here. So the thing that immediately jumps out to us is that this is a circle, and this is a circle with center 25, 20. So if we let a comma b be like x, y, then we'll have the center. This is the center being 25, 20, and the radius of the circle is equal to 5. But what does this tell us? So we have a circle here with the center, and this is radius 5. Well, notice how this is a line. This is just a line we converted into standard form. And so for this to have exactly one complex solution z, this equation number 2, which is a line, has to be tangent to the circle. Because it can only meet the circle at one point a comma b, because that would make z have exactly one solution. And so, okay, so now we've established that this line has to be tangent to the circle. But that still doesn't really tell us anything. Like, that's great, but what do we do? Well, if you know the distance formula between a line and a point, then we can make an equation with that. And if you don't, there's a really good derivation process that you can do with linear algebra. So the distance basically between a general line ax plus by plus c and a point x0 comma y0 is going to be, that distance is basically going to be the absolute value of ax0 plus by0 plus c over the square root of a squared plus b squared. That's the distance from a point to a line, which is the perpendicular distance. And of course, a tangent is perpendicular to the radius. So that means that the distance from the line to the circle has to equal the radius's length, which is 5, which is what we established here. So we have ax0 plus by0 plus c absolute value over root a squared plus b squared equals 5. So equals 5. And so now we just have to plug in our values for a, b, c, x0, and y0. Note that the point x0, y0 is the center, because the distance from the center to the line again is equal to the length of the radius. So let's just plug in those values real quick. Okay, so if we plug in those values, then what do we get? We get 8 times 25 minus 6 times 20 minus 8k minus 7 over the square root of 8 squared plus 6 squared, which is square root of 100, which equals 10. And this is equal to the length of the radius, which is 5. Again, this is the length from the line in equation 2 to the center of the circle, which is 25, 20. And that has to equal exactly 5, because again, we have a tangent line, the radius is perpendicular to this line, and that has to equal exactly the radius's length. So that's what allows us to create this equation. And from here, it's pretty straightforward. We find that there are exactly two values of k because we have an absolute value thing here. So then we get, okay, so 25 times 8 is 200 minus 120, 80 minus 7 is 73. So we have absolute value 73 minus 8k equals 50. And so from here, it's pretty easy to see that k equals 123 over 8 over 23 over 8. Okay, so summing these two values, we get 146 over 8, which is 73 over 4. So 73 over 4 is m over n, and so 73 plus 4 is 77, and that's just the answer for problem number 8.